Good evening, seventh graders. It is Mr. Sarley, and you are on your YouTube homework review. This week on our homework, we are reviewing something you learned in fifth grade, which is multiplying whole numbers by fractions. And let's jump right into it. The first problem says 5 times 1/4. So the way you probably learned to multiply a whole number like 5 times a fraction like 1/4 is by first turning the whole number into a fraction. And so you're probably taught that 5 is the same as 5 wholes, or 5 over 1, and we can multiply that by 1/4. And when you multiply fractions, you just multiply across. So 5 times 1 in the numerator would be 5. 1 times 4 in the denominator would be 4. And this would be an improper fraction. That would be the answer, but you could also rewrite it as 1 whole and 1/4. And it's fine. If you did that, that's totally fine. But I wanted to show you how this is the exact same as this. Because if you think about what multiplication can mean repeated multiplication, or a repeated addition. So 5 times 1/4 is the same as 5 groups of 1/4. So if we were to solve this one, we'd have 1/4, 2/4, 3/4, 4/4. That would be a whole, and then one extra fourth would be 1 whole and 1/4. Obviously, this is the same as 5/4, and you can see that these two problems are related because they're equivalent. So I wanted to give you both ways to think about it, because this is a process, but this is a concept, and I really want you to understand the concept. So same idea for C and D. In C we have 3/4 plus 3/4 plus 3/4 plus 3/4. If I think about that, that would be 3, 6, 9, 12/4. And 12/4, let's convert that into, well, that's more than one whole, right? Because 4/4 would be a whole. So 4/4 would be a whole, 8/4 would be 2 wholes, 12/4 would be 3 wholes. And you could have also just thought of this as 12 divided by 4 is 3. So that's our answer. And if we come down here, we have 3/4 times 4. Again, that literally means the same thing. We're taking 3/4 of 4, which can be thought of as just repeating 3/4 4 times. But you could have also done it the way you probably learned it in 5th grade, which was take the 4, rewrite it as a fraction. That would give you 12/4, and that's the exact same as what we got up over there, which would give us an answer of 3. All right, and on to reviewing other things we've covered on homeworks before. 1/2 plus 1/4. Now we can't just add these together yet because the fractions aren't the same size. One is a fourth and the other is a half. So what we do is we want to make the denominators the same. So I'm going to write an equivalent fraction. 1/2 is the exact same as 2/4. And you can multiply the numerator and denominator by 2 if you want to. So this is 2/4, and then 2/4 plus 1/4 is 3/4. For G, it says 2 3/4 plus 1 1/2. And to do this one, I guess what I could do first is I could add the whole numbers. So 2 wholes and 1 whole would be 3. And then what I'm going to do is I'm going to add the fractions, 3/4 plus 1/2. And I know from this problem over here that 1/2 is the same as 2/4. And now that the denominators are the same, I can add, and I would get 5/4. So in total right now, I have 3 wholes and 5/4, but I'm going to rewrite 5/4 as 1 whole, because it has more than 4/4, and 1/4 left over. And then when I finally add this and this, I would end up getting 3 4 wholes and 1/4. So if you got 4 and 1/4, congrats, you just added two mixed numbers together on your own. F says 3/4 times 4/5, and that one's really simple. I'm just multiplying across. So 3 times 4 is 12, 4 times 5 is 20, and then you really should try and simplify fractions if they're not in their simplest form. And I noticed that 12 and 20 both have a factor of 4, so that means that this fraction is equivalent to 3/5. But both of these are the correct answer. All right, and finally, H should look exactly like G because it is, right? 2 plus 1/4, that's the same as 2 and 1/4. We just don't write the little addition sign between the 2 and the 3/4. So I would solve this one exactly like I did up over there. The 2 and the 1 together make a 3. I did a lot of work in the first problem to figure out that these two fractions make 1 and 1/4. I'm not going to do all that math again, and I should get the exact same answer, 4 and 1/4. All right, so on the back, we're reviewing ratios again, which is probably the biggest topic in all of middle school math. So Richie scores 4 points every 10 minutes. That is a ratio, 4 points for every 10 minutes. At this rate, how many points will he score after 30 minutes? A really strong strategy is the double number line. So I have points on top, minutes on the bottom. 0 to 0 is always the starting ratio. And then I'm going to go ahead and put the ratio the problem gave us, which was 4 points every 10 minutes. And now just think about it. If another 10 minutes pass, that will be 20 minutes in total. And Richie scores 4 points every 10 minutes. So another 10 minutes would be another 4 points. Another 10 minutes would be another 4 points. How many points does he score after 30 minutes? Well, that would be 12 points. We could have also used a ratio table, which I started to set up. You start with your starting ratio of 4 to 10. And then from there, it's basically the same idea as this, right? Every 10 minutes is another 4 points, but because we're adding over and over again, we can just use multiplication, which does the same thing, but shorter. So to get from 10 to 30 minutes, which is what we're trying to figure out, I see that I could use a scale factor of 3, and I'll use the same on top, and that takes 4/10 and finds, or 4 to 10, to get this new ratio of 12 to 30. And again, that's a different way that you could have got our answer. If you used a different strategy, but you still got the same answer, then that's totally fine. With ratios, you can solve them any way you want. At this rate, how many points will he score in 5 minutes? All right, so if our starting ratio is 4 points for every 10 minutes, and then it's asking us about 5 minutes, we have to take this rate and break it up into a smaller but equivalent rate or ratio. And I see that to get from 10 minutes to 5 minutes, I could take this initial ratio and divide it in half, which would give us 2 points in 5 minutes. So that would be our answer. And this is where it's kind of cool to look at the double number line, right? I think someone from 704 asked what's the point of a double number line if we're just going to sort of make a table anyway. And the point is so you can see the actual breaking up of ratios. So like from here to here, that's 4 points and 10 minutes. But if we're looking for half of that, we take this amount of space and we split it. And so you can really see that this ratio is being cut in half. And then you could go by that ratio over and over again if you wanted to. All right. Hopefully that makes sense. All right, so I just finished grading all of your vacation packets, and they were spectacular. Some of the best assignments I think any of my students have ever done. Um, Daniel from 7 of 4, his assignment is kind of funny, as well as being really good. So if you read this first part, um, it brings tears to my eyes knowing that after this page you will be done with this unit, and I will no longer write you anymore. You have grown up so fast, and then he starts crying, which was pretty funny. But on each page in his packet, he had the problem solver level up, and at the end, you became the integer champion, king of the king's master. And so I'm going to take a page from Daniel's book, and the secret words today is going to be integer champ. Thanks for checking this, guys, and I'll see you in class tomorrow.